This is the Precalculus Fall 2016 ACP Preview Problem 32. The Texas Department of Public Safety collected data on the stopping distances for a number of types of cars. They found that one brand's stopping distance could be modeled by the equation y equals 0.05x squared plus 0.1x plus 5, where y is the stopping distance in feet and x is the speed of the car in miles per hour. If the car required 100 feet to stop, what was its approximate speed just before beginning to brake? So you're basically solving a quadratic equation. I'm going to write out, we know that y is our stopping distance, and we're given that as being 100 feet. So our equation is going to be 100 equals 0.05 x squared, and x being our speed, and then that's going to be plus 0.1 x plus 5. And to solve this equation, there are different ways. If we subtract 100 from both sides of this equation, we're going to have 0 equals 0.05 x squared plus 0.1x, and 5 minus 100 is going to be minus 95. And we can use the quadratic formula. We can solve by graphing. I don't think something like this is going to be too easy to factor. Maybe it's factorable, but I don't know that it will be. What I'm going to do is suggest using something we've done in the past called numerical solve. Now, one thing we have to keep aware of in using numerical solve is that with a quadratic equation we could have two right answers, so it's possible that none of these could work out to be right when you work out, because in your numerical solve you're going to only see one of the possible right answers. Let's try it anyway. We go to menu 3.1. We have 100 feet, which is our stopping distance, is equal to 0.05 x squared, and x being the speed for braking, plus 0.1x plus 5, and we're going to press comma x, and we get 42.6005. That sounds about right. And it turns out that that looks like answer choice A. You could, let's also solve by graphic. Put this second equation in here, see how that looks like. So if we go to Control I, add graph, and we put 0.05 x squared plus 0.1x minus 95, and if we graph this, we see nothing. Let's go ahead and expand the, remember speeds are going to be, our real answer was 50, right? So if we go to window zoom and window settings and set that x max equal to 50, we should see our right answer here. Go down, and here we see this is going to be at 46. We can check our 0 here, analyze, menu, analyze graph, 0 says lower bound. We go to left side, we go to the right side, we get 42.6. So a lot of different ways to do this. Another way I haven't even talked about is we could take these answer choices, like if we tried answer choice C, we could plug it in for here, for this x here, and this x here, and see if we get close to 100. Obviously we wouldn't, and we could try the different answers until we worked out a lot of different ways of doing this problem. I'd like you also to consider looking at problems 32A and 32B for supplemental practice. Good luck, and thanks for viewing.